Hi everyone, welcome back to the series where I go over the Brain Facts book. This video series is meant to be helpful for the brain bee. So yeah, let's get into it. Today we're going to be talking about the evolution of the brain. So all human brains or all mammalian brains are thought to evolve from early vertebrates. So things like the Osteosarcans, and more specifically, the human brain is thought to most closely embody the modern lancelet known as the Ammoxophis. So let's take a quick anatomy lesson into this. Right? So we're not going to focus on all of these because the buccal, mouth, pharyngeal, gill slits, these are all animal specific. But let's focus on this piece, the cerebral vesicle and the nerve cord. So according to the names, I think you can already guess that this foremost bulge was supposed to be the brain of the lancelet, and the nerve cord was supposed to be the spinal cord and also did some processing for it. So in the cerebral vesicle and nerve cord, there were three bulges similar to what we see in the normal human brain, which was the forebrain, midbrain, and hindbrain. For now, let's focus on the first two. Or actually the first and last one, forebrain and hindbrain, because the midbrain came after a few more years of development and a little bit after some more evolutional parts, because as we talked about in the last video, the midbrain is mostly responsible for thinking, processing, emotions, etc. So that didn't come until a little bit more evolution. So the forebrain actually was responsible for olfactory bulbs and light processing areas. So let's think about where the Ammoxophis lives, right? The Ammoxophis is a vertebrate that lives in water conditions and lives in like conditions where it needed to detect chemicals and it needed to be able to process its surroundings. So that's why the chemical detecting areas evolved into the olfactory bulbs, and the light processing areas were essentially the equivalent of its eyes. Then in the hindbrain, it was responsible for timing and coordination. So I think this phrase timing and coordination is associated with something really common that we talked about in the last video, and you'll be hearing it a lot more, which is the cerebellum. So the hindbrain, or the third bulge, was essentially the Ammoxophis's cerebellum. So to continue on with this, as time came about and as mammals and other animals started becoming more complicated, the neurons in the brain, or the forebrain, more specifically, that gives us all of our personality, our complex thinking, our executive function, started to balloon more. And the reason for this is because an increase of a special class of neurons known as interneurons. So these don't have a specific function. They're not specifically for auditory, specifically for visual. What they do is they connect everything together. So there are neurons that specifically process auditory information, specifically process visual information, but to get from one information to the other, the interneurons connect these. And that's the reason that the forebrain bulges. That's also the reason why humans have become increasingly smarter, because there are more connections being made. So as you can see here, the Semiri forebrain is really small. The macaque, it's a little bit less complicated. And then the chimpanzee, you can see quite a bit of resemblance to the human brain. And you can see how the forebrain has gotten massive over the years. And according to what each species needs, that's how much the evolution occurs. So let me rephrase that. As you can see here, a mouse needs a lot more of critical thinking to hide and furrow, and it does a lot of executive thinking. That's why its forebrain is a bit bigger in comparison to any other pieces. And now let's take a look at the human brain. We need a lot of space for movement. We need to be able to think. We need to be able to process. We are social animals, so that's why our forebrain is so much larger. And even our cerebellum is significantly large because we are very moving and we have very fine and delicate movements that need to be precisely coordinated. So that's why our cerebellum also bulged. And things like these are what determine how animals evolutionize, even in the brain. What you use the most is where your brain will develop the most. So yeah, that's a video on evolution. And if you have any questions, please feel free to reach out, email me, and yeah, thank you for watching. Bye-bye.